on osmosis. When you talk about osmosis, osmosis is also an example of passive transport. It does not require ATP or energy, just like diffusion. But it is different from diffusion because water is the one that moves. And it moves across a membrane, just like what you see here. The movement of water is from higher concentration, from more water, to lower concentration or to less water, across a semi-permeable membrane. This is what it says in the book. And we will be testing this by doing this 2 setups to prove if this is really true. So what we'll be doing is that we will be setting up 2 setups. One is hypertonic and one is hypotonic. And as we proceed, I will explain to you the differences between hypertonic and hypotonic. Now, let's begin with these 2 jars. We have 2 small jars here. They are about 250 ml jars. And right here, we have a 250 ml graduated cylinder. And by the way, a lot of students ask, did the graduated cylinder really graduate? It did not. The only reason why it's called a graduated cylinder because it's a cylinder and it has those lines which we call as graduations. So it's a graduated cylinder. Okay, if you hear somebody say that the cylinder has graduated, then that's another cylinder. Okay, so we have this graduated cylinder, and what I will do is that I will fill this graduated cylinder with 200 ml water. Okay, and here's the water. I will pour it to the graduated cylinder up to the 200 ml mark. Now, when I read the volume of the water, I make sure that the graduated cylinder is on a flat surface, and I align my eyes with the 200 ml. It needs a little bit more. Okay, so that is 200 ml water. We have a 200 ml water here. This is the 250 ml mark. That is the 200 ml mark. I will now transfer the 200 ml water, and this water, by the way, is tap water, into the small jar. Okay, so we have it there. So this is the first jar. And the second jar will also fill it up, but then I'll be putting in about 50 ml of salt. Of course, salt is solid, we should weigh it, but this time we'll just be measuring it by volume. This is a lot of salt. Okay. Okay, that's close to 50. Now, I will pour water into this graduated cylinder with salt until it reaches the 200 ml mark. Okay. Check. Okay, it's exactly 200 ml. The next thing that I will do is that I will stir the solution so that the salt would mix. So this is now a solution of salt. Salt and water, that is. The solute is the salt because it's the one that I dissolved. And the solvent is the water. Now, I will transfer this 200 ml of salt solution into the second jar. Okay, there it is. So we now have two setups here, but this is not yet complete. Now let me ask you, this is tap water. It's water from the faucet. This is tap water with a lot of salt. We define hypotonic as having less solute, and as I mentioned, in this case, the one that we mixed was salt, so the solute is salt. Hypotonic, it has less solute, and it has a low concentration. While hypertonic has more solute. Thus, it has a higher concentration. So, hyper means higher concentration. Hypo means lower concentration. And lower concentration means it has less solute. While higher concentration means it has more solute. Now, let me ask you, which of these two small jars has less solute? Letter A or letter B? Which has less solute? Christina, is it A or is it B? Very good. A has less solute. So that means this has more solute. Okay? Now, tell me, Alex, which of these two jars is hypotonic? Is it letter A, the one with less solute, or is it letter B, the one with more solute? Which is the hypotonic? A or B? Okay, anybody who would like to help Alex? Yes? A or B? It's A. So this is hypotonic and this is hypertonic. The hypertonic is the one that has more solute. Third question. Which of the two setups have more water? Letter A, they're both 200 ml. But which of the two has more water? Letter A or letter B? More water. Letter A. That's correct. Because this one has 50 ml salt added to it. So, we now know the difference between hypertonic and hypotonic. Now, let's prepare the cell. I'll be putting more salt in here. And then, I will get the dialysis tubing. It's called the dialysis tubing. I soak them overnight so that I can easily open them. Okay. Now, I'll be using a panel to make sure that the solution would go in. Okay? Now, with this one, I will just be putting plain tap water. Okay. I will remove that. So it's almost like an ice candy. Have you made like an ice candy? Yeah, I do that all the time, but I'm not good at tying them though. My wife is. For some reasons, she's always better than I am. Okay. See, I told you. Okay, need to do it nicely. Okay, there it is. I need you to remember how it looks like. It's not that loose. It's a little bit tight, okay? But not that tight. Now, if I compare this dialysis tube with water inside to this one, which is the hypertonic? This one, the dialysis tube, or the one in the jar, which is hypertonic? The one in the jar, or the one, letter A, the jar, letter B, this one, which is hypertonic? The jar. Very good. Because it has more solute. So we call this setup now hypertonic because the environment of the cell, we consider this as the cell because of the cell membrane. We consider this as the hypertonic setup. And I'll put this inside, and let's see tomorrow what will happen to the consistency of this one. Will it become bigger or will it become smaller? I'll put it inside. Okay, see that? This is now the hypertonic setup because the environment of the cell is hypertonic. So when we describe a setup, we describe it based on the environment. Now, the next thing that I will be doing now is the one with the salt. Then I have to mix it. And then I'll get another dialysis tubing right here. Then it's a challenge to open them, but it can be done. And then I'll use another one so that it won't contaminate. I'll insert the funnel because without the funnel it will be hard to put in the liquid. Okay, now with this dialysis tubing, I'll be putting salt solution. Oh, that's a mess. Go inside. Okay, it's now going inside. Okay. Sorry about that. Okay, so that's it. Putting that there. And then we have this one now as the setup with the salt solution. Okay, look at the consistency. Now, let me compare this to this one in the jar. Now, between this and this, which is the hypertonic? Letter A or letter B? Which is the hypertonic? A or B? This is A. This is B. Which is the hypertonic? We compare the two. Is it A or B? Is it B? When we say hypertonic, it has more solute and it has higher concentration. Which has more solute? This one or the one in the jar? Letter A. So this is hypertonic. That means the one in the jar is hypotonic and the one in the jar is the environment. So we will call this setup as the hypotonic setup because just like this one, you can see here, there is no salt here. This is a hypotonic setup. We name the setup based on the environment. This one here represents the cell. Okay, I will now put it here. Look at the consistency. And right there. So, hypotonic setup, hypertonic setup. And now, we'll be observing today before you go home, and then tomorrow when you come back, and see if they change. The thing that we'll be observing is that where will water go? Will water go into the cell membrane or into the cell? Or will water leave the cell and will go to the environment? If the water leaves the cell, then the cell will be limp. If the water goes inside the cell would swell. Okay? So that is what we'll be learning. Thank you.